Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we are going over Clean Code by Robert C. Martin. Today, talking about Chapter 12, Emergence. If you guys remember last time, we discussed Chapter 11, which was all about systems. In that chapter, some of the main points we talked about was this concept of how you would build a city, and then analyzing that, or analogous to that, how you would build a piece of software. And we talked about how components of software don't necessarily have to know what the other one is talking about. Similar how I gave the example in a city, the people who build bridges probably don't have to know how the people who build houses do what they do. Software, we talked about abstracting things out. We've talked about that earlier too, single responsibility principle and such, that classes should only have one reason to change, right? So in systems, we talked about a couple different concepts. One of them was dependency injection, and how we use dependency injection to give the responsibility of dependency creation to other classes. So we talked about constructor injection, where you literally tell the constructor, hey, use this to instantiate your own dependencies, versus that class doing it on its own. We talked about how dependency injection is a concept or an implementation of inversion of control. Again, you're inverting the control. You're giving the control to an external class on how your dependencies are built. And then we talked about aspects and aspect-oriented programming, which is used to cut down on cross-cutting concerns by building aspects, or things that can intercept processes and manipulate them in a certain way before and after. So we saw this with Spring, has a aspect-oriented programming built into it, and you can annotate things with the @aspect annotation and so forth. So that was last time. Today we're going to talk about emergence. And what do I mean by emergence? Well, this is kind of have something to do with simple design and clean design. Now, some of these concepts that are going to be laid out here are going to be stuff that we've talked about previously in this book. So the author starts out by saying, according to Kent from his book, Kent Beck's 4 Rules of Simple Design, a design is simple if it follows these rules. And then this is a very short chapter. It just talks about these 4 rules, and they go in priority. So number 1 priority is that they should run all tests. If a design is simple, it should run all the tests, and all the tests should pass. So it sounds simple on paper if your design makes sense to you, makes sense to your team. And this is really simple design. So it sounds simple on paper, but if there's no way to verify it, says Martin, well, then is it really that simple? If there's no way to verify it, maybe it's still simple in your mind, but if the project doesn't build, then it sounds like something's not really too simple. Or it sounds like if you don't have tests to verify it and validate how your code works, then you can't really test its simplicity. Systems that aren't testable aren't verifiable, and he goes on to say that they should not be deployed. But if you make your design simple enough, and you have classes and functions that only do one thing, and you have good naming conventions, then it's easier to write the tests. It's easier to cover code that's simpler versus more complicated. And you can do this. You can ensure this by making sure that, hey, your classes are small. They have a single purpose. Your functions only do one thing. So it makes writing the tests easier. And then the last bullet point, when you do code cleanups, if you write tests, you have no fear that things got broken. So if you have tests and you go to refactor your code or you clean it up, the test is going to help you that your code still functions the way it should. Because if you go to change something, you run all the tests, something breaks, well, okay, then you know there's an issue. There would also be an issue if you change something, it breaks, but you didn't have a test for it, so all the tests that you do have pass. Now, all of a sudden, you think everything's hunky-dory, you go to deploy it, and something's not right, something's not working. So you write tests to quell the fears that things might get broken in code cleanups. So that's the first rule, is if a design is simple if it runs all the tests. A design is simple if it contains no duplication. And this is what Robert says is the primary enemy of a well-designed system is duplication. And we've talked about this before earlier in the book. But duplication can come in many forms. And the most obvious form is, hey, literally lines of code that look the same. So you have just tons of, print statements that are just printing the exact same thing. Well, why not just replace all those print statements, abstract it out into its own method, and just call that method? So now you only have one place to change if that print statement ends up needing to be tweaked a little bit. But there's also duplication of implementation, says Martin. So you might have some methods contain similar lines of code. You can then extract those into another method. I mean, this part I didn't really get because it sounds exactly the same as, just if lines of code look the same. And I totally get that. This part just kind of seemed, these duplication of implementation and duplication of lines of code, it seems like the same thing. It just might be different where you find them. And I actually did have an example here. Here, was this the good example? Okay, I think this was a good example of no code duplication because you have a process order and an update inventory that both call this calculate total price. Now, there is code duplication here, right? However, wouldn't it be worse if this calculate total price, which is down here, if you had this for loop, if you were doing this calculation in each of these methods, I think that's what Robert Martin is getting at, is the code duplication that you might find if you take what's in the body of calculate total price and you put it in the bodies of update inventory and process order. Then it would make sense to abstract it out into its own method here, calculate total price. And yes, is there code duplication still in both process order and update inventory? There is, but is it as bad as if you were to put this for loop in each of those two methods? I don't think so. And I think this looks way cleaner. So again, a design is simple if it contains no code duplication. And then in the next section, Robert talked about this pattern, or rather, this was within the section where he's talking about no code duplication. And he introduces this pattern called the template method pattern, which is something I'd never heard of before. But this pattern allows subclasses to override certain steps of your algorithm without changing the structure of the algorithm. So you have an abstract coffee template. You have this algorithm. This is your algorithm, preparing the coffee, which contains, looks like void methods that are void, 4 of them. These are also methods that are a part of the abstract class, but they're abstract methods. So pay attention to that. So we're going to need to provide implementations for these 4 methods: boil water, brew coffee grounds, pour in cup, add condiments, all that. But we have this algorithm that is actually going to get called whenever you want to start preparing coffee. You're just going to call prepare coffee. You're not going to call all 4 of these separate things, and I'll show you what I mean by that in a second. So it's going to allow you to change the steps of your algorithm but not the order in which the steps get implemented. You're not going to be able to provide your own implementation of prepare coffee, but you can provide your own implementation of boil water, brew coffee grounds, pour in cup, add condiments, etc. Let's go to the next slide because this is the example continued here. So coffee with milk extends coffee template. You also can do, coffee without milk, which is what you see in the main method there. I didn't provide the screenshot of that one, but it looks is pretty much the same, except you're doing it without milk. But this is going to extend coffee template. And then looky here, it's going to provide its own implementations of those 4 methods that are within the algorithm of prepare coffee. And then when you, in your main method on the right, when you create a new coffee with milk, when you say prepare coffee, you are going to prepare the coffee in the same order as it was here, but you've provided your own implementation for these in that it's going to look a little different than if you called, when you create this coffee without milk, and you call that prepare coffee. So if I did have the screenshot here for coffee without milk, you would, here in the add condiments, you would just maybe dedicate this print method to saying adding oat milk, because it's without milk, right? So you're going to provide your own implementation for that. So that's kind of how that works with this template method pattern, which is something new to me. I never knew that you could do that. And it kind of did seem confusing at first, like, oh, we're changing these methods, but we're not changing this method. Oh yeah, this is the algorithm. This one is the one that you can't change. I'm guessing because of the abstract keyword. But the methods within your algorithm, these are going to be the ones you provide your own implementation for. And you're not going to be able to change the algorithm. The order is going to stay the same. You can't change that. But you can change the innards of that algorithm. Let me go forward. Lastly, a design is simple if it is expressive. What I mean by expressive? Expressive means it's easy to understand what the code is doing. So Robert writes, it's easy to write code that we understand, but it's hard to write code that other people are going to understand, because we're always going to understand what we write because we wrote it. It sounds, it's very intuitive, but it's the way that I write code is going to be different than the way somebody else writes code. So it's writing code for the other person in mind. We've talked about this before earlier in the book. A majority of the cost of software is in this phase of development where you're just maintaining, fixing bugs, etc. So the clearer you've made something to start, the clearer it's going to be for other people who come in and maintain the code to understand what it's doing and then better be able to diagnose, fix the problem. The clearer something is, the less time others are going to spend understanding it, so that it takes less time to deliver on maintenance requests or bugs that come up and delivering fixes for them. So Robert talks about you can express yourself by doing a lot of these things that we've talked about earlier on in the book. You can express yourself by having good function and class names. You can express yourself by keeping functions and classes small, single responsibility. A class should only have one reason to change, right? You can express yourself by having just standard nomenclature. If you're using patterns, include the pattern name in the class name. I know I included a separate bullet point for that, but make sure if there are standard nomenclatures that you are using in your code, make sure you use them throughout the whole code. Like if you have, instead of when you are using lists or array lists, don't name the variables that you assign those lists to, don't name them list. Use singular, not singular, but what's the other word? Instead of saying like task list, just say tasks. Use the plural. That's what I'm looking for. The plural name. Don't include list in it. Or maybe, and I know we've talked about that's a little redundant to name something list when you know that it's already array list, but I don't know, maybe that's just the standard of your project. So follow whatever standard of naming that your project, your team has put forth just throughout your whole project. Use camel case, when you have your methods or variables. We talked about that. If you're, as an example of standard nomenclature, if you're using a pattern, if a class is a certain pattern, then include that pattern name in the class name. You can express yourself also by writing really, really good tests that cover your lines of code and that test the functionality of your code. And you can express yourself by just trying. And Robert talks about, I think he has a very good point about this. But the most important way to be expressive is to try. All too often we get our code working and then we move on to the next problem without giving sufficient thought to making that code easy for the next person to read. Remember, the most likely next person to read the code will be you. So take a little pride in your workmanship, spend a little time with each of your functions and classes, choosing better names, splitting large functions into smaller ones, etc. So just try. Try, and I bet you that you will, by that nature, just make the code more expressive, even if you just try a little bit. It's like, if you guys remember, I did the videos on the 4 agreements, and one of the 4 agreements is always do your best, and your best is going to look different each day. Some days you're going to score 20 points, some days you're only going to score 5 points, but as long as you do your best, you can't be mad. And it's just some days the shots aren't going into the bucket, but you still did your best that day. So just try. Whoops. And lastly, I don't think this wasn't a part of those 4. Oh no, it was. Okay, so a design is simple if it also has minimal classes and methods. And I know what you're thinking here, but classes and methods should follow single responsibility. If your classes and methods are doing too much, you should abstract the functionalities out that are not particular to that method and just create a new method for them. Very true. And this is something that, I kind of just thought to be dogmatic about this. Oh, every class is only just going to have one function. But now Robert comes back and he says that we could easily abstract functions and classes into infinity, which is true. But there comes a point where it's too much. And I guess all in all to say, yes, single responsibility principle is a good rule. It's a very important rule, but I guess what Robert is saying in this section, just don't be dogmatic about it. Don't be dogmatic about it to the point where you just have tons and tons of classes, tons and tons of functions that are only doing one thing. Because he says you should try to keep those class counts low. And I actually put lower because I think it's still a good idea to probably do single responsibility, to use the single responsibility principle, but just don't use it to infinity, is what he's saying. And again, the list that we've just gone over, these 4 tenets of what something that is designed simply looks like, out of all of them, this minimizing classes and methods rule is the last one. It's the lowest priority one. So just remember that. The most important one was it should run all tests. Then it should contain no duplication. It should express the intent of the programmer. And then lastly, it should minimize the number of classes and methods. And this one is the lowest priority. So just remember that. We're not saying don't ever abstract functions and classes. In fact, you should do that, but just try to keep it tasteful, I guess is the best way of saying it. But in conclusion, oops, this was a shorter slide. shorter chapter, guys. Last slide. These principles are based on the experience of many, many different developers. So they're not just out here willy-nilly like Kent Beck, who wrote that book, Simple Design. He's not just saying this, randomly. This comes from years of work in this field and trying things out and seeing what worked and what didn't work. So the principles are a good idea. Again, there's a priority to them. And again, maybe overall, don't try not to be too dogmatic about things, but follow the rules as, best as you can. And in the end, practice good habits, practice the principles of clean code, not just from that we talked about in this chapter, but, throughout the whole book that we've talked about so far. And I think at the end of the day, just try. If you try to write clean code, if you try to work in this manner, then it's like a compound effect, which is, it's funny enough, it's a book that I have that I thought about doing it for the channel, where just small wins and small progress just snowball into like a huge success down the line, to where your whole team's doing it and your whole project all of a sudden is transformed into something that's way cleaner, easier to read, very expressive, etc. So just try. Guys, that's going to do it. Thank you very much for listening. Next time, we're going to talk about chapter 13, which is concurrency. I'm kind of excited for this chapter because concurrency has always kind of confused me a little bit in Java. So looking forward to that. Guys, thank you very much. Again, appreciate you sticking with me, and we'll catch you in the next episode. My name is Chris. This has been Chee-Tash. Take care, everybody.